We're very pleased indeed to have with us here today David Rebus, who is at the University of Michigan. He's a postdoctoral researcher there at the moment. We have a great deal of interest in what David has to tell us because of the Oxford e-Social Science project here, which is looking at the social aspects of e-research, and that is also the area that he's going to tell us about. He has been studying e-research or eScience or cyberinfrastructure, as they called it in the US, for some time. He did his thesis about that at the University of California at San Diego. And I'll stop there because he's, I'm sure, going to tell us all about that. David.
Thank you very much for that lovely introduction. Also, thank you for having me. So, strategies of the long term in infrastructure design. The talk is going to focus on comparative studies of multiple cyber infrastructure projects in the US, and in particular focus on the strategies that people have employed in these projects to deal with the concept and the problem and the planning of the long term. Before I get into it, though, I'd like to start with a little preface to set the agenda and set forth some of the ideas that I'll be drawing on. Before you have the clock of the long now. This clock actually came recently to London. It was here probably 2 or 3 years ago. It was designed by Stuart Brand. He's sort of an icon in a variety of environmentalist icon, sort of a digital guru, and more recently headed the project to design the clock of the long now. So the clock of the long now, it will tick once a year, chime on the century, and cuckoo every millennium. It's a clock that's designed to last for 10,000 years. Now, it's in some sense it's more of a thought piece, and I draw your attention to it because I think it pushes our thinking in ways that we're not used to doing. It's a piece of technology that is, it does not stand alone. It can't be thought of as standing alone. As Brand says, we're going back to the early excitement about clocks. They were big, they were monumental, they were something that a city would organize itself around. The clock in Prague, the clock in Venice. So it is a piece of technology. But it is also, as Brand keeps noting, it's also a question of how to organize its maintenance. So in other words, yes, it is a piece of machinery with cogs and gears that must be made to last or think to last 10,000 years. But he never conceives of it, Brand and his team, never conceive of it as a standalone product that's just going to go. It is tied to human work of maintenance, people who are going to oil it, people who are going to wind it. Without the attention, it will not last 10,000 years. And thirdly, the question of institutions. Where is this clock going to be? Where could we put it in the world? And what organization, what group of people, institutions, could support its maintenance for 10,000 years? And that's quite the question, if you can imagine. What city lasts for 10,000 years? What area is safe from earthquakes, from damage, from water, or from being forgotten if it's not wound and maintained on a regular basis? So this is the concept of the long now. And actually, the word long now comes from Brian Eno. And let's see, 3 years we've been working on building a 10,000-year clock. So this was actually finished in 1999. This is and it's been touring, and they're planning to build yet another one that will be housed in, say, the Rocky Mountains somewhere in some safe spot. But the idea here of the long now is that we stretch the now, the instant, beyond the idea of technological turnover with, say, information technology with the internet. We stretch it beyond this and think about the long now in terms of going back 100 years, forwards 100 years at least, or maybe even 10,000 years. This is the idea of the long now. And I want to keep coming back to these concepts. First, that the long term is something that we work on today. And second, that the questions are both or triply technological, institutional, and organizational. So what am I going to talk about, outline? First, I'm going to define this business of cyber infrastructure. Second, I'm going to focus on the long and whose term. So whose long term am I talking about here, and what does this mean? Third, I'll outline a narrow typology, drawing on some of the ideas that might be the problems of the long term today. again, emphasizing that the long term is something that we're working on now. And then lastly, I'll describe a strategy drawn from my studies, an explicit strategy, which is called the two-tier approach. Throughout the entire talk, I'm going to be discussing strategies of the long term. It's going to be what these people have been doing, these people designing and building and enacting and maintaining cyber infrastructure. What have they been doing to think about the long term, to plan and deal with it? However, at the end, I'm going to focus on an explicit strategy that people have come up with in the project that I studied for my dissertation for thinking about the long term. So here, the differences being that I'll be talking generally about long-term practices, but usually these aren't thought of as such, and the last one really does. All right, so what is cyber infrastructure? Here we have the revolutionizing science and engineering through cyber infrastructure. This is the more fondly known as the Atkins report. Published in 2003, it really popularized or crystallized the idea of cyber infrastructure in the US. The Atkins report is the sort of the short name. Feel free to interrupt me at any point in time. One of the disadvantages of cyber infrastructure that it quickly turns into alphabet soup. And so if I fail to clarify at some point, please do interrupt. Primarily, cyber infrastructure as a movement, as an idea, is centered around the National Science Foundation, the NSF, which is the national funding body for science in the United States. Another term I'm going to keep coming back to, so NSF. And let's see, cyber infrastructure is intended to be a single thing. So it's not multiple cyber infrastructures. It is intended to be one single cyber infrastructure for the sciences and engineering across the United States, possibly across the world in the more ambitious statements. These projects are, whenever I see this, I'm drawing a lot of slides from my subjects, from the people I've been working with and studying. Whenever I draw one of their slides, I'm going to indicate it with this little star here, in order to let you know they're not making an argument so much as I'm drawing from the kinds of ways that people think about cyber infrastructure. So in this case, this is drawn from Dan Atkins' slides. Dan Atkins, again, so he was the chair and headed this report that I was discussing on the previous slide. Now he has become the director of the new Office of Cyber Infrastructure at the National Science Foundation. So at the time, that didn't even exist. There's been a restructuring of this federal institution for science support in the US that now is organizing the questions of cyber infrastructure, funding them, and consistently doing studies and building them. So all kinds of projects come under this header. Physics, biomedical research, brain imaging, ecological observatories. The cyber infrastructure can range from a concern with the production of data simply to its management. The projects that, the only project here that I'm going to be discussing today is GEON, which is my dissertation research project. This is the GEOsciences network, and I'll just describe this more in detail. I draw from some other comparative studies as well, though. So let's just get on the same page about what this business of infrastructure would be. As I understand, people often make a commonsensical comparison in the US saying that eScience is the same as cyber infrastructure. Frankly, I don't know, and I'm going to defer to the expertise of the people in this room to tell me to what extent that is true. And so I want to define what we mean by cyber infrastructure, in particular infrastructure. So first, infrastructure, then, I draw these three terms from a classic study, or now classic study by Susan Lee Starr and Karen Rollader, Steps Towards an Ecology of Infrastructure. They define a series of different terms, and I'm going to just focus on three for the moment. These terms, although they're social science terms in some sense, map very well onto the concerns and focuses of cyber infrastructure. So first, cyber infrastructure is long-term. I'll leave it at that for the moment. Second, it is useful to a broader community. So although it's designed by particular sets of people, it should serve a community. In other words, GEON should serve the earth sciences writ large. BERN should serve the bioinformatics research community or brain imaging community. SEEK will serve the ecological scientists. So the idea is always it's a small group of people that builds something for a larger community. And lastly, transparent to that community, eventually infrastructure should support the work of scientists or engineers and then disappear. It shouldn't be something that's constantly breaking down. It shouldn't be something that has to be managed. It should be usable. It should be relatively transparent with the interests and the needs of scientists as they already exist. All right, so having covered infrastructure, let's cover this business of cyber. I'm going to focus just on two terms here. First, interoperable scientific data, and second, tailored domain applications. This is, again, drawn from the Atkins report, become very popular. Interoperable scientific data. We envision an environment in which raw data and recent results are easily shared, not just within a research groups or institution, but also between scientific disciplines and locations. This will only take place if all share standards and underlying technical infrastructures. So in other words, what's being captured in this idea is that data should be able to move across the barriers of institutions, of disciplines, of location. Data being stored in different kinds of institutions of science, say United States Geological Survey, by a small independent group of scientists working off one particular location, should be able to be shared very easily across this entire infrastructure. So this is the idea of a unified infrastructure. Tailored domain applications, this is the other side. Cyber infrastructure should be produced and managed in a way that enables research communities and projects to tailor efficient and effective application-specific knowledge environments for research and education. What does that mean? Along with this idea of a universal data movement across different disciplines and locations, you want to have the data being brought to individuals or disciplines in their terms. So visualization tools that are designed for those communities, resources that are for them, rather than some sort of generic, this is the generic side. We want the data to move freely, but we want the data to be brought to the different communities and processed in their terms, by their standards, by their visualization tools, by their modeling methods. So let's get a little bit more specific. GEON, Cyber Infrastructure for the GEOsciences. This was my dissertation research. It is well, I'll describe that in a second. Here's the portal from about 3 years ago, the web interface, and you can see this for yourself at geongrid.net or geongrid.org. What do they want to do? They call it end-to-end functionality. In other words, that you'd be able to start with databases, go through visualization, modeling, put it through computing cycles, which will also be available on the supercomputing, on the infrastructure, having results. So from the point end-to-end functionality, from the point of collection of the data all the way to the point of using it in order to find kinds of new scientific knowledge in scientific practice. What does GEON actually look like then? When I joined GEON, they were this group. So I came in to study GEON, or to work with them right from inception, essentially. They had been funded already, so they had received their grant, which is about $14 million for 5 years. And they didn't have any infrastructure at the time. They didn't exist as anything, essentially, but this network of people. There were no computing. There was nothing physical about it. There was no software had been developed. So I started pretty early. They also don't have a real location. They're distributed across the US, but they do have their technical core at the San Diego Supercomputer Center in San Diego. So one of the really nice things is here is the social science building cut off from the picture, and I could just sort of leave and walk down this path and be at my research site, where everyone would come down on a regular basis. What does it look like? What are these people? What do these people actually do? What are they? The way that is usually parsed out is to say that they're information technologists or computer scientists and domain scientists, earth scientists. So you can see here the team of computer scientists or information technology researchers, and here the team of geoscientists. Most of these are at the Supercomputer Center. Most of these are distributed across the US at various other kinds of institutions. There's also education and outreach as a concern. And having said all this, there is me, who also joined the team officially with them. They brought me in as a social scientist. I'm trained as a sociologist initially. Social science is often the generic term that's used in cyber infrastructure to describe anyone who's not a computer scientist or a domain scientist. And they asked me, I should be honest about this too, they initially invited my advisor, Jeff Bowker, to join the team, and they got me instead. So I was intended to conduct, they brought me in really with a concern that there was going to be conflicts along this boundary, that computer scientists and earth scientists would have a lot of difficulty communicating, coming together, designing technologies which are going to be useful for the earth sciences, and also meeting the needs of research for computer scientists. So I was here as a sort of a communications expert in some sense. So having introduced myself, let me just make a couple of notes on methodology. And when I say methodology here, I really want to emphasize that these methodologies are the methods for generation of theory as well. My primary approach is grounded theory, especially in this talk. But also I draw on ethnography and actor network theory. Let me just say a couple of notes about each one of these and why it's relevant for this talk. First, for ethnomethodology, my primary focus here is members' orientation towards their activities. In the next section, I'm going to talk about what is the long term to these people and these projects. I'm not interested in defining what is the long term, or even in particular, what is a good strategy. What I'm interested in doing is following the ways that they might try to deal with the long term, how they conceive of the long term, what is it to them. Second, actor network theory, follow the actors. This is the idea that you don't pick your topic in advance and stick with it. You pick an object of observation, which are people in this case, and as they circulate, you follow them around, follow the actors. What does this actually mean then? It comes back to this clock business at the beginning. Even though GEON seems like initially it would be a standards body, building infrastructure, technologies, computing resources, in practice, when you actually follow people's work, you find that they go to all kinds of places that have nothing to do with technology or infrastructure. So many of the participants in GEON would go to the Geological Society of America, the annual meeting of geologists. They would regularly interact with the National Science Foundation. They would be regularly in contact with other kinds of information technology projects. So in other words, GEON quickly overflows any conventional definition of technical work. It is all kinds of other work at the same time. And there's no one, I'm not imposing this on GEON. I'm not discovering all this other activity. They know this very well. There's a lot more to a GEON than a technology project. And this is true, I think, of any infrastructure building project, as you'll see. Lastly, so my primary emphasis is grounded theory, development of substantive theory to render comprehensible and researchable participants' activities. In other words, what I'm interested in doing is understanding what they are up to and coming up with fairly simple theoretical tools for understanding what kinds of activities they're engaged in. And finally, constant comparison. The comparisons of this study are not the comparisons of, say, difference and similarity, Mill's method. This is a constant comparison of grounded theory intended to generate insights, intended to understand projects in general. It's a theory building process rather than a formal comparison.
Could you just say a word about the disciplines on which you draw?
Mm-hmm, absolutely. So I'm trained.
A substantive theory of what these people are doing?
Sure. All of these traditions, in one way or another, can be defined as sociological. So if you want, do you want names? Or it's hard to pin down exactly how to speak about something like that. Ethnomethodology was innovated by...
No, I was thinking just about the grounded theory.
Oh, sure. All right. So...
I mean, you talk about developing grounded theory.
Sure, absolutely.
They're comprehensible what they're doing.
Mm-hmm. This is a tradition that was innovated by Anselm Strauss. He was a sociologist of the Chicago School. I am a student of Susan Lee Starr, who was a student of Anselm Strauss. So there's sort of a nice little lineage that I can point to there. Does that answer your question?
Well, it's a way of answering it, but then it doesn't tell me how you would proceed. You're following people around.
Sure.
Them visiting various sites.
Sure.
And you have a theory about what they're doing.
Oh, no. Okay, so the idea would be that it's an inductive process to some extent. So the idea that you begin relatively somewhat without theory. You begin with a series of methods and following them. So all my methods are ethnographic, recorded, entire set, all of the, I was with them every single day, essentially, as an ethnographic practice is drawn from anthropology, the idea that you go to other peoples and observe them as others. So with GEON, I was with them on a regular basis, recorded all the conversations, sometimes used video cameras as well, had a transcriptionist do transcriptions of those as well, conducted many, many interviews over those 3 years that I was with them. And now, how do you develop this? I think let's come back to that question. Yes, inductive approach.
but it's not framed with reference to any analytical content. No analytical framework.
A process, yeah.
It's a process. It is a process, yeah.
Looking at what people do, and you.
There are a series of.
You don't refer to anything.
Yes. There are a series of concepts that have been developed out of it, but the idea is that they would be substantive theory, that they wouldn't actually necessarily apply outside of those situations, short of you doing a lot of work to make them. Some of the popular concepts are articulation work, that's come from Anselm Strauss, boundary objects from Susan Linley Starr, but it's difficult to take these theoretical ideas that were developed in one place and move them to another, because you're supposed to be developing, yes, very inductively, some local ideas. Boundary objects were initially devised to explain the relationships between collectors in museums and the museum staff. And so it's been exported by other people, but it was not initially intended to do so. Oh, good Lord. Okay, but let's serving multiple meanings. Let's move on and come back to this question. Maybe by the end of the talk, it'll make a little bit more sense what it mean by developing substantive theory. So first, let's begin. So the long and whose terms. Whose long term is this? I'm going to start with. We've already introduced GEON. I'm going to introduce LEAD as well, linked environments for atmospheric discovery. And for the purpose of this talk, I can really treat them as the same, as you'll see. They're both cyberinfrastructure projects. They also have 4 letters in their name, and they both are rather dramatic in being LEAD and GEON. They're both cyber-infrastructure projects. They're both data management and tool-oriented. In other words, they are not instrumentation. They don't produce data. They don't have facilities producing quantities of data that will be processed, but rather want to deal with the already existing data within these communities. Earth Sciences, they're both from the Earth Sciences, and they're both funded by the NSF at approximately $13 million. They're both also, and perhaps most importantly, come out of a program called Information Technology Research. I'll describe this in a moment, but so what is the long term of these two projects? What are they looking for? How far ahead are they looking? And really the answer is 5 years. Now, what I mean by this is a little bit more than the fact that their funding cycle was 5 years. They both have funding for 5 years. What do I mean by long term of 5 years? What I mean is they're unable, in many senses, to know what is going to happen to these projects after the 5 years, even though they initially look ahead and plan for something beyond those 5 years. They're both infrastructure projects. They're both designing tools for a community. They're interested in being around for longer than 5 years, but they're having a very hard time. Long and whose terms? Where did this business of ITR come from? I'm going to do a little bit of setup here. This is a slight bit of policy analysis. ITR became an NSF priority area following the influential President's Information Technology Advisory Committee report of 1999. The PTAC report, as it's called, was initiated by President Clinton and Al Gore as a study of the next generation internet, in some sense. What are their findings? In short, that federal funding for information technology research was either flat or had been declining for over a decade, and that existing support was focused on narrow, short-term goals and immediate application. In other words, there was a sort of a sense of concern that information technology research was not being well supported across the US state, and that whenever it was being supported, it was focusing on quick, short applications, very short research projects, maybe a year, 2 years, 3 years. PTAC recommendations. Strategic initiative in long-term information technology, visionary and high risk. Though it is often said, and it is, I suppose, quite true, that the PTAC led it directly to the information technology research program. Information technology research had these goals in mind. They were going to be long-term by the standards of research, so funding up to 5 years, which is quite a bit longer than the 1 to 3 year grant cycle, which is much more common. And also there'd be visionary and high-risk research. Very important that we keep this in mind, this business of research. So ITR became an opportunity to fund infrastructure building projects. It was never intended to be such in the beginning. Essentially, the 5-year mark of funding, which was long-term by these standards, and the possibility of having, say, $10 to $15 million a year, over 5 years, produce an opportunity for this idea of cyber infrastructure. So GEON, LEAD, and other programs in the ITR. ITR, by the way, ended up being about $1 billion total over 5 years, of which maybe 10% of those projects could be called cyber infrastructure in any definition. So after 5 years, the question is, what's going to happen next? With GEON, what you had on a regular basis is questions about who's going to fund us after this. NSF made no promises following this program. They simply they said, okay, well, maybe we'll fund you, maybe part of the GEOsciences directorate, but if so, it would be at a much lower value than we'd given you before. And one possibility that GEON was engaged with on a regular basis was looking towards the United States Geological Survey, another institution in the US, maybe joining up with them. But if they did so, all the technologies they'd been developing for the last 5 years would be a little bit off from those kinds of goals. From being an umbrella infrastructure meeting the goals of earth sciences, they would become serving the geological survey. Or another possibility was to join up with another large-scale information project. Another possibility was the project would simply shut down. So from the very beginning in the GEON project, and as well in the LEAD project, atmospheric research, the ITR projects have this problem very consistently. They didn't know what would happen to them after 5 years.
Do we?
Pardon me?
Do we know what will happen to us after 5 years?
This, well, if you're thinking long-term, perhaps.
Maybe I've lost the thread somewhere. There are two notions which are floating here. One is the notion of the life of a formal program with projects which have a budget cycle and have an authorization in a funding agency. The other is the somewhat vaguer epistemological concept of the program of research, which is carried forward by people who have a sense of common purpose and mission, and they fund it in any way that they can.
Exactly.
And they keep it going.
Exactly.
So we should, when you talk about the long term, are you trying to keep both of these concepts in play?
There's a third concept, which is, will the software catch on?
Well,
Then it has a life of its own.
All right, let's return to that concept in a moment. So I'm going to continue a little bit. Yes, you're absolutely right that there's two floating around at the same time. I do want to maintain that. Why? Because they maintain it in their own activity. In other words, as an infrastructure project, these visions of GEON and LEAD are not part of information technology research per se. They were funded out of this. Each one of these projects considers itself to have its own identity that was funded under information technology research. I'm going to come back to this idea a little bit later when we talk about some of the conflicts that occur within the ITR program. Let's do a quick contrast now with another infrastructure project that exists in the United States. This is called Long-Term Ecological Research, or LTER. So what is as you can imagine, long-term ecological research has a different basis of our understanding how their long-term plays out. LTER is a federation of ecologists with the goal of understanding biomes and creating data sets that match time spans operational within ecosystems. In other words, LTER has set itself the goal of maintaining data, of maintaining itself and maintaining its resources at the same length of time as is operational within ecosystems. And they simply define it as observation of long-term change is central, yet some ecological changes take place at scales that match or exceed human lifetimes. LTER has managed to, has existed for 20 years now. It's only sort of retrospectively called itself Cyberinfrastructure, as many projects in the US have done as the program has grown in popularity and importance. So this is from 2001, just one of their slides. They're able to think ahead about 10 years quite comfortably, and often longer than this. They know that their funding is become a line item, as they like to put it, a line item in the National Science Foundation budget. They will not be cut unless there's some change in policy. They will be able to renew their program for every 6 years. So here out of some of their own publications, in response to the clear need for research extending beyond the traditional 2 to 3 year grant period, NSF began in 1980 to support research on long-term ecological phenomena in the United States. The renewable 6-year grants are independently peer-reviewed and renewed by the National Science Foundation. NSF conducts comprehensive reviews of the entire LTER program every 10 years. So every 6 years, there's 24 members in this group. Every 6 years, those members have to renew in one way, but not compete against each other. Every 10 years, the entire vision of LTER is reviewed. So they've had 3 reviews so far, or sorry, their 3rd review is just coming up.
This is raising a difficulty that I have, which is, where's the cyber in this?
Where's the cyber? Oh, I'll get to that. So far we're talking, you're right, so far we are talking very much about policy. What I'm trying to do though is not, I'm trying to set right now what the idea of the long term is in these projects, and then we're going to get a little bit to the technology, although that will never be the focus of this talk. You'll see why. Lastly, the longer than usual funding cycles provide a harbor for activities such as multidisciplinary studies, network participation, and community change and discussion. There's a lot of sense in this project that they have the freedom to change the trajectory and direction of what they're doing on a regular basis. So what is the long in terms of LTER? It's 150 years or more is the way that they like to think about it. The changes that are going on in ecological systems are things that go well beyond the span of a lifetime, even obviously a career, and they span to 150 years at the minimum. It doesn't really have a sort of an end goal. They envision themselves to be preserving data for very long periods of time. They like to look backwards as well to projects started in the 19th century for collecting information. Just as a sort of I'm not going to talk about this, I'm going to quickly go through this. Cleaner is another project that I've been studying. Their scale of time is about 25 years of infrastructure development. This is usually considered when people talk about infrastructural time, 25 years is probably the most average score. So I'm going to go through that one quickly. All right, so am I saying then that, where's the cyber in this? This has all been shifting, this has all been about institutional terrains and funding cycles. Am I saying then that these projects are all determined by their funding cycles? The long term is determined in these areas? Absolutely not. Each one of these has different kinds of sets of concerns. One that regularly appears then is technological turnover. Each one of these projects is supposed to be infrastructure that lasts beyond a few years, and yet information technology today is changing constantly. What do they do about such things? The reason why I'm going to talk about this least is probably because this is the most explored and formalized and funded question within infrastructure design. In other words, GEON, for example, uses ontologies for information integration. Multiple data sets drawn together by ontologies, mediation. Other kinds of approaches that are very typical are the development of metadata, knowledge management techniques. These kind of things are very well studied and I don't think we've got them pinned down by any means, but at the very least, they are addressed on a regular basis through funding, through policy questions, and by scientists themselves. So here's an ontology. Why develop an ontology? They are conceived and understood very much in terms of long-term support of data. So for example, the questions of legacy data, the reuse, or the preservation of data. So we have, yes, shifting institutional terrains and technological turnover as 2 concerns. I want to add a 3rd question in addressing the future, which is organizing for sustainability. Along with technology and along with an institutional terrain, what these people are continuously concerned with is how are we going to preserve this thing? If you go back to the clock again, it's not just that it's a piece of machinery, and it's not simply that it's going to be housed in one kind of location. You also have to have work around the preservation of that thing. So organizing for sustainability. Let me go back to LTER. One of the interesting innovations that they have, which I actually have not seen, and it definitely doesn't exist in any of the projects that I've studied, is a group of information managers who are within that group. In other words, LTER has 24 members and has 24 information managers that meet once a year. The LTER data managers meet once a year. They have a representative at each site. They have an executive committee. They have newsletter, and they have a growing research component. There's all kinds of rules within LTER that sort of demand this. LTER was created with the idea of preserving data in the long term. So, they also had the idea of releasing data within that network within 2 years. They also had, they have developed an ecological metadata language, so a standardized language for coding data, thus making it available to move across those LTER sites. And for example, they've developed a unit dictionary. Each one of these 24 sites might have very different kinds of terminologies that they use within the group. And so they've created a dictionary which catalogs the different uses of terms and allows different people in the network to collaborate with each other. The growing research component, this explains why I was working with them. I worked with an information manager at one of the sites called Karen Baker. Some people might know her here. She's become increasingly involved in information science circles, and drew in a series of social scientists as well to study the practices of data maintenance. That's how I was working with her in the beginning. I don't want to make it seem as though, before I go to there, I don't want to make it seem as though LTER is peachy keen. They still have enormous amounts of problems with the visibility and the importance of these data managers. What you'll see if you track the movement of the information manager group within LTER, over the last 10 years, they've shifted more and more to a research component, attempting to move away from having to fill the demands of scientists being a servant, a group of essentially technical servants, moving towards being researchers and being able to have a certain amount of autonomy and determination of what the technological structure in LTER will be. So they speak about this problem regularly. We don't do things that are in the metrics that the principal investigator community value. We don't write multi-million-dollar grants. We don't publish a bazillion papers every year. We are too busy getting the work done out the door. So based on the metric that most of the traditional scientific community uses, we are pretty invisible. They speak regularly. Oh, this is also conducted with Helena Karasti, who's a scholar here somewhere nearby. They speak regularly about the problem of having all this weight of responsibility on their shoulders, and yet technology is changing around them. The information manager is supposed to keep up with the new technologies of ontologies, of distributed data sources, and yet they're also supposed to keep up with daily concerns and research within LTER. So with this tripartite group here, institutions, the technology, and the organization of the maintenance, this is how these groups have come to address the future. But even this does not cover the full problems of the long term today. Along with the future vision, they also have a set of concerns that are very much in the present. So along with addressing the future, they must satisfy the present. I'm going to talk about these quickly as research versus production, quality systems, and career trajectories, which really tie together. As I noted, the GEON project was funded as a research project. They have a great deal of impetus from the National Science Foundation to produce new scientific knowledge about the Earth, but also new scientific knowledge about computer science. And yet, probably most people in this room understand that a research system, an infrastructure produced for research, for producing new knowledge about computer science, is not necessarily a production quality system. In other words, they regularly are unstable, not suited to the needs of users, often designed to prove a point. So proof of concept is often what it's said to be. A demonstration which only has limited functionality. These are the qualities of research systems. Production quality systems, of course, are stable, easily usable, extending across time. And so there's a great deal of tension between those two. Not only this, but this ties into the question of research trajectories. Many of the participants in the projects that I've named thus far, LTER and GEON and LEAD, are PhD scientists. They have interests in their own careers very often. They have a need to publish, to produce something new, to produce knowledge about the Earth or computer science. And so on a regular basis, they speak about, and you'll see later on, they speak about the conflict between producing new research, working in their own careers, and the kinds of needs that you have to go into a production system, which are not very research-oriented very often. So things like knowing the user community, conducting user studies, producing massive amounts of metadata to catalog a database, which is very work-intensive and yet not particularly rewarding on the research frontier. They're not able to publish about these things. Lastly then, and here we get to the strategy of the long term, linking the present with the future. So it's at least possible to understand how you produce a production quality system. You send out people to study the community. This is fairly well entrenched within information science methods, requirement solicitation, usability studies, entire series of methods designed to make systems available to users, usable. And functional and meeting their requirements. That's possible. And also we've seen that it's also possible to address the future through kinds of technological interventions, having strong institutional ties. What is really a problem, or at least these people express it to be a great problem, is linking the future to the present. How do we meet all of the needs? So, example strategy, the two-tier approach. This was developed within GEON. This is what they speak about regularly. As I've said, I've been talking about kinds of strategies regularly throughout the talk. This is the only one that I've encountered that has made it extremely explicit. They've sort of taken on many of the problems that I've addressed here and tried to tie it together in what they call the two-tier approach. So here's a slide drawn from one of the PIs in GEON. I've highlighted the part that's about the two-tier approach, although in general it fades across. The two-tier approach use best practices, including use of commercial tools and open standards where applicable. That's tier 1. Tier 2, while developing advanced technology and doing computer science research. I'm going to try to break this down a little bit more by going into, I'm going to need some patience here and some listening as I go through 4 different slides that are going to go through a single interview and try to characterize what they mean by this two-tier approach. How have they parsed the world, and how are they going to address the problems that I've brought up? So first, let me introduce them each individually first. First, the interviewee is going to parse the question of, from the perspective of geoscientists. Why don't geoscientists want to build infrastructure? What are the problems there? Then he's going to go on to talk about why computer scientists or information technologists find it very difficult to build infrastructure. And then lastly, he's going to tie it together in this two-tier approach. So, the idea of infrastructure is kind of new. People don't get that. In the past, something has been a scientific problem. We need to solve this. He's speaking in the name of a geoscientist here. We need to solve this. I need a really huge computer. I'm really going to focus laser-like on getting my big computer, run my job on the computer, and I'm done. All this nonsense about creating this cyber infrastructure so that everybody can use this big computer, I don't care about that. So the idea that you could actually be spending effort on creating a broad-based infrastructure is still a little bit new. So he's characterizing here the geoscientist as interested in producing their own data, not very interested in collaboration, not gaining necessarily any rewards in the career stream of production of knowledge, publication, etc. Information technologists, why don't they want to build infrastructure? In software engineering, there used to be, the old world was what they called the waterfall model. Our guys here in software engineering say, I built this thing, now you should use it. When they really mean, I built this thing, it may or may not work, why don't you use it and tell me if it broke and I'll fix it. It is very hard for people to work with such software. So the way that he characterizes the computer scientists, as we see, they're interested in producing new tools, new knowledge about computer science, proving a point in computer science, which often means a proof of concept, building a demo, but not necessarily in producing a functional tool for the user. This is often also called throwing it over the wall as a method. In other words, that on one side of the wall is the user, you don't see them, you don't care about them, you're sitting on your side, you throw them a tool and you're like, hey, just use it, make it work for you. So what's the two-tier approach in his characterization? In the case of GEON, say, pick the Rocky Mountains as a variable. That's the driver. So stop here for a second. He uses the term driver to explain the tie. You would have earth scientists working very closely on a daily basis for years at a time with computer scientists. The scientist drives the development of technology. But how do we achieve that? The driver just tells us, this is the problem we are trying to solve. We're trying to understand the tectonics of the Rocky Mountains. That tells me that I need these kinds of data sets of the Rockies. I need data sets of that. I need these kinds of models. But then, how do I build it? And I think the two-tier is going more towards how you build it. Okay, we now know the driver, and it will take 5 years to build it, during which time you'll lose all the scientists. So 5 years is just too long in the research trajectory of scientists. They can't survive for 5 years without publications, without new knowledge about the Earth. They would lose them if they developed the system as they would like to. Okay, we know now the driver, and it will take 5 years to build it, during which time you lose all the scientists. So I say, no, we'll do something quick. Put together whatever data sets are available today. They might be dirty, people might not like them, but that's what we've got. In 6 months, we have something, while you're building the more fancy thing in 2 years. That's why I'm calling it the two-tier, the fast tier and the slow tier. So we see the problems that I've described in the earlier section parsed in a relatively similar manner. In other words, we've got the short-term demands of producing a technology, a nice technology for the information technologist, but also producing a tool, visualization tool, data processing tool that is useful for producing science. Secondly, you have this long-term development using the latest technologies, using stable production quality tools in order to build an infrastructure that other people will be able to use as well. So the short term is meeting people's interests immediately, long term meeting long-term interests of a community of infrastructure development. So I'm going to quickly conclude and wrap up two points that I've tried to draw out about their practices. First, that the problems of the long term today can be parsed along the boundaries of addressing the future, in order to thinking about how to design systems in long term, but always having to satisfy present circumstances. Thirdly, that there's always an idea of linking the two, and these are strategies of the long term. If we want to understand what are the strategies of the long term, we need to address institutions, technology, and organization together at the same time. In science studies, this is often called an assemblage, if you follow Latour's work. But the idea that whenever you change one of these, you're going to change the other. If you develop an ontology, you're going to have the kinds of support to maintain the standards that are built into that as language changes, as data changes. You're going to have the institutional support to be able to do that as well. There's a tripartite tie between these three objects. Thank you.
David, did you begin with the long-term question? Or
Absolutely
that
not.
came out of the,
Mhm.
okay, that's one of the concepts you tried to develop to understand what's
Absolutely.
going on.
In fact, it's
Okay.
difficult to even say that the long term is a question within GEON,
Yeah.
the first project that I studied, because it lasts 5 years. And yet I realized more and more that the kinds of concerns that they're addressing and the kinds of concerns that they express about after those 5 years are long-term questions. So that's why I started doing those comparative studies with other groups that had been long-term.
Okay. Could I just, one example to tie in with Paul David's comment about the difference between a project and programs is, I mean, often in developing programs of research, you design it to kill projects. I mean, literally, by killing projects, you create new investigators, you get rid of dead wood and
Right, exactly.
I mean, that is part of the strategy of long-term program development, is to make sure projects don't last too long, you know. I mean, so
Sure. So I think that has to be a little bit different when you're building infrastructure, though, because the idea would be that you would come into the system and be able to use it. If the tool that you're relying upon, a community of people are relying upon to use in their regular research, simply disappears after a certain amount of years, then in some sense it's not infrastructure at all, right? It's a liability to the community. The community is very unlikely to invest in something that they don't feel will be there to support their research after a certain point of time. A couple of the technical concepts that they draw out here would be modularity, the idea that you would be able to unplug, that you'd build systems in such a way so that you can disconnect one chunk of it, say a visualization tool, and plug in a new one, and yet still maintain the same system. So again, I'm not going to talk very much about those, but there is a series of technical fixes or technical ways of addressing the question of ending a project and starting a new one.
Ted.
Yeah. Ted Nelson, Oxford Internet Institute. First of all, Stuart Brand is my next door neighbor in California, so I have a special take on that. But so many people try to build for the long run and fail
Yes,
because you don't know what will catch on.
exactly.
In the 70s, someone was building TCP/IP that was going to become the internet, but almost nobody knew it.
Right.
Meanwhile, there was the ISO standard, which was marching on at full speed, and IBM had QTAM, BTAM, and the rest of those things, all of which they thought would be central. Of course,
Yes.
they lasted too in the IBM world.
Yeah.
But you're speaking as if those noble and enlightened individuals who decided to program for the long run will definitely succeed, whereas in fact there's no guarantee of success. And what you think at a certain time may be the cat's meow, like ontologies, might well not stand the test of time.
Thoroughly true, and in fact, chances are pretty good that most of these ITO projects will not continue. I would say that ontologies is an idea that's been reinvented at least 5 times and applied in various different manners, everything from expert systems to knowledge bases, and it was one of the core ideas in artificial intelligence.
But you don't see the one being, the data from one being transferred onto the next.
You absolutely don't. You're absolutely right. I do not want to make any commitment to the success of this strategy. My interest is in understanding what is going on in the field. In other words, I think we have a very poor understanding of what people are doing when they're doing things that they think are going to be long-term. And if we want to possibly design long-term systems, we at least need to know first what is going on the ground. In other words, we need to know what are they doing, what are the concerns of people who want to do something like a long-term. And their concerns are things like satisfying their career trajectories today, building, having support in the long term in terms of institutional support, so the concerns that I identified here are their concerns, not necessarily mine per se, and I don't want to make any commitment to the functioning of a 2-tier approach. Rather, I want to identify what are people doing, what are they doing on the ground, and then later maybe we can do some comparative studies and say which ones are more functional and which ones aren't. This is nowhere near that.
But as academia rambles on in its various directions, concepts come and go. For example, 40 years ago I had an office in the Mini Cumnock Blodgett Hall of Euthenics.
Mm-hmm.
Mini Cumnock Blodgett donated the Hall of Euthenics to Vassar College with the idea that euthenics would be the unifying concept of the social sciences.
Sure.
I won't even try to tell you what it was.
Right. Sure. I mean, we can point to many of those moves in computer science too, cybernetics being a really good example.
Well, cybernetics exists, it's just not what people thought it was.
Well, all right.
Let me come back to a question which was floated earlier. In what way are the processes which you have been studying in the context of cyber infrastructure distinguished or distinguishable from any one of a number of processes that are observable in all the other domains of human activity? If you turn yourself to the question of what were the people in the 18th century who were building canals doing? Or what were the people who were building any of the other large systems that we see as having survived in some sense? Or what were the people who were organizing knowledge into the encyclopedia of the Enlightenment? What distinguishes? Is there anything that distinguishes the sort of way in which you've approached these processes because it's in the digital domain, because it has to do with science as opposed to some other application, technology and
Sure.
engineering?
Sure.
Would you muse on that a little bit?
Sure. That is, I mean, it's the good question, and I'm taking it that you expect you would ideally like there to be differences, or?
I just want to know whether this has ever occurred to you.
Oh no, of course. Yeah, of course.
What did you think about it?
Whether I'm identifying possibly some very general features of planning in the long term.
Well,
I might
what
be.
I was sort of getting at, you studied a particular set of social processes.
Sure.
Correct? And you didn't go outside the domain of the cyber infrastructure for a reference point.
Sure.
But it must have occurred to you that there might be some other reference points outside.
Absolutely.
Which would help us to understand whether is there something special about the cyber infrastructure challenge, or is this just something like all the other things that become cultural products of,
Sure.
of societies which get themselves fixed on doing something which they think is of importance?
Sure. So
What's new?
Uh-huh.
Is there anything new, or maybe not? Is this a universal framework that you have, which could be applied to everything?
In this talk in particular, yeah, I tried to make it as general as I could, which is funny because usually my tendency tends to be in the other direction. But I wanted to start addressing a question. What I've usually done in my talks is something like, let me introduce GEON, let me tell you about their specific problems, and then at the end of that talk, what I would usually get is, so what's the point? All you can say is that they have these sets of problems within GEON. What are we supposed to do with this? And so actually, by doing these comparative studies, I was hoping to make a little bit of a more general statement. And so I guess for the 7 years that I've been a graduate student plus postdoc, having looked at 5 projects, is about as much as I can handle right now. And so what I'd have done, of course, is cover the literature and see if, say, in the building of electrical networks, in the building of a railway network, is there some comparable issues? Is there some differences? And yeah, I would say that there are distinctly some differences. For the most, I mean, and the idea that it's science, I think it really does come down to that. The idea that you have to build new knowledge at the same time as you're building infrastructure is something fairly unique in these projects. I don't know if you can think of other examples. In another talk, I called it twice basic research and infrastructure to boot. So in other words, they have to do earth science.
Is it your view that engineers don't create new knowledge? Or is you define?
Oh, well, cyber infrastructure.
This is because it's science that the people who built electrical supply networks weren't having to solve new scientific problems.
Well, having to solve new scientific problems is a bit different from having a demand to produce knowledge for knowledge's sake. So in other words, when they're studying plate tectonic movements or the rise of plutons through the Earth, this is a new piece of knowledge that they have to develop that has nothing to do with the infrastructure itself. The Earth scientists must produce knowledge regardless of, it might have nothing to do with GEON as an infrastructure, but they must be producing new knowledge or, their careers, A, will go down the drain, and B, NSF will be very dissatisfied with the results of an information technology research grant, which will be considered a failure for not having produced earth science knowledge. So I think that's a fairly particular, and of course, there are, for example, the Cleaner Project as engineers, as environmental engineers, they also had to produce new knowledge, but it's not infrastructural-based knowledge. It's not about infrastructure. It's knowledge about hydrological systems in the U.S.
So is a distinctive feature of the process you study the fact that the National Science Foundation has sort of tasked research communities to become involved in creating a durable set of tools, and is that a consequence of Susie Iacono's disappointment with the outcome of the Collaboratories program, in which people built something which was technically new, which answered a series of difficult questions in distributed research, but they found that those projects sort of didn't catch on, in the sense that the tools that they built were very specific to the research groups that built them, that they had very little spillover.
Yes.
And that what you're seeing now is an attempt to do take two, which would have a more lasting infrastructure deposited.
You've identified a very key strategy within cyber infrastructure. That you're absolutely right. I don't know if it is Susie Iacono. I mean, it might be her. It might be a new and emerging philosophy.
Susie Iacono was my project officer. She got me into studying why it was that the Collaboratories project didn't spill over.
Right, that's interesting. I mean, she's commissioned quite a few of these studies in some sense. She's also commissioned the KDI studies, and she's very interested in the failure of these systems. There's an interesting quote from Cyber Infrastructure that very nicely characterizes exactly what you're saying. I didn't bring up in this particular, but from the Atkins report again. Only domain scientists and engineers can revolutionize their own fields. At its core, the ACP involves rethinking the cyber infrastructure involves rethinking the processes and methodologies underlying individual scientific and engineering fields. Domain scientific and engineering researchers must step up and enthusiastically create and pursue a vision. So you're absolutely right, and you've identified something in their strategy rather than my analysis, but you're right. In most of these ITER projects and in all of the new cyber infrastructure projects that are starting to emerge, like the plant cyber infrastructure that's being funded now at $10 million a year, half of them are scientists and half of them are computer scientists, and the expectation is that those plant scientists, those paleobotanists and plankton studiers in the ocean will all produce knowledge about those things while they're building infrastructure at the same time. Not knowledge that's related to the infrastructure. And so yes, that's that tension. You're right.
Can I ask something before? I mean, I also want to continue that line because I mean, I think when you defined what you mean by cyber infrastructure, you forgot, I think, a really obvious way to kind of make it much more specific, which is that these are electronic networks for sharing computing resources. And in that case, you're cutting out dams and electricity networks.
Functionally, what difference is there?
No. I mean, I'm just saying, if you wanted but in any case, my question was this.
My question, Ralph, was that what difference did it make that these are electronic networks?
Yeah. No, and I think
as for the analysis, I can think of dimensions which make a big difference.
Yeah.
But that didn't seem to come into the analysis of what was going on, or the tensions which existed between the vision of having, on the one hand, saying only domain sciences can revolutionize the way in which they pursue work, and the sub-thought, and only domain sciences don't want to spend the time doing that because the incentive structure within which they work says that is, that way lies death, because you either produce results which are the basis for your next grant proposal and your publications, or you build infrastructure, which we don't want to fund. Okay? We're trying to get a grant to maintain infrastructure.
Use instrumentation, which is presumably instrumentation to observe specific
geological formations, phenomena, yeah.
But does that mean then that if you are simply putting together new data in new software forms or new computer science-driven forms, and if you are simply developing the software to be able to do that and to somehow network it, that to you wouldn't be part of a kind of domain science application of
to me?
infrastructure?
Oh, this is not about me at all.
Right,
in fact,
right. But I mean, I'm just wondering because you.
But do they? Okay,
instrumentation, you could say is this is building cyber infrastructure, building tools for processing data or for somehow linking data. That could in itself be seen as a scientific or indeed engineering project, and I'm just wondering.
I need to answer that in terms of their concerns, though, because I mean, I'm not the one deciding whether or not this counts as science. This is actually a living debate within every single one of these projects. They regularly bring in their graduate students, and a geoscientist will bring in their graduate students and have them participate in this project, maybe creating metadata about a database that they know really well. But they're earth scientists. Does producing a whole slew of great metadata within the geosciences count towards getting a job, tenure, publication? Not right now, is what they tell me. They say, no, absolutely. This person will never get a job in a geoscience department and will not be considered a geoscientist. They need to go out in the field with their hammer and collect some rocks and create some data and know something new about the Earth. Now, this is constantly in debate within these fields. So they want to create, say, GEON is very interested in creating a geoinformatics journal in which these sort of new hybrid creatures, these new hybrid graduate students who know a lot about information and know a lot about the Earth will have somewhere to do their work. It's a long and enormous process to change such an institutional arrangement. I mean, fine, you create a journal. Does that mean you have a department? No, that doesn't mean you have a department. Does that mean you have a funding agency? Does that mean you have credibility amongst your scientists? No. But, they're working on it. This is an everyday concern in these projects.
I think it was Bill.
Michael. No, go ahead,
No,
Michael.
Peter. All right. Thanks. I have a quick question, just if you don't mind returning just to railroads for a moment.
Okay.
You mentioned the distinction between cyber infrastructure and other types of infrastructure being partly...
No, that wasn't me.
Didn't you say it was partly driven by the science? Was a differing aspect?
Keep going.
But doing science was what was one of the fundamental differences between the development of cyber infrastructure and, say, railroad type infrastructure.
When I was pressed into making distinctions, then I made that distinction. It was not based on my empirical research.
Allow me to keep that distinction for a moment, because of course the other way of comparing it would be doing science on the one hand, making money on the other hand. And if you're developing infrastructure like railroads and so on, I would imagine if it's done in private enterprise, you're going to pick the points which you connect very carefully in the short term to ensure you're making money even though you're in it for the long term.
Sure.
I wondered in terms of development of cyber infrastructure, whether you had looked at other models whereby there are short-term gains in terms of other types of business model in the development of cyber infrastructure, which is not necessarily dependent on top-down funding from funding agencies, but other ways of developing, say, charging models or so on for cyber infrastructure that can have the gains in the short term, but still demonstrate you're in it for the long term.
Have they done so?
Yeah, if you looked at those, have you looked at any?
Well, I mean, that was in some sense that was the idea of the two-tier approach, right? That you would, in that very last quote that I showed, that you would be what he called the fast tier, right? That you would be developing a series of tools that serve immediate purposes, and I can point to several one of those. So, for example, in one case, they developed a visualization tool. It was nothing but maybe a day or a week of programming in which they developed a visualization which they call the beach ball. It represents focal points in seismology, the ways that the Earth hit against each other. This tool existed as something that they would draw in the past, or as something that they would use a fairly crude visualization program. And they adapted the visualization and moved it into GIS technology, Geographic Information Systems technology, so that everything that all the data that they were attaching to it would be interoperable, further can be drilled down on it, etc. They did so as what they call the candy technique as well. They offered a very simple, very short-term tool to a community that they felt was in need of this tool in order to bring in more users. So they've adopted a series of strategies for developing very short-term, small contributions that would entice the community, make them think that GEON, hey, has something interesting to offer, and then maybe 5 years down the line, when the really big tools that they want to develop, like ontologies or workflows or other kinds of data integration, are stable enough to be used, then the user will already be there, in some sense, because of these short-term commitments. Does that answer your question?
Yeah, I just wonder if there was some alternative underlying economic model to the development of cyber infrastructure, other than continually applying for grants. I think a lot of the talk concentrated on a very top-down approach to the funding.
Oh, okay.
So
in GEON, they've only, well, I mean, they've formed partnerships with a series of small organizations of business organizations like Esri, which is the largest provider of GIS technologies, at least in the U.S. They have ties with IBM, et cetera. But these aren't going to be, no. The answer is no. These aren't going to be the long-term solution for them. All of their long-term funding source solutions have been kinds of institutions.
Thank you. Yeah, could I wonder if you push your history back further, that you find that the impetus for this didn't come so much within the computer science community. Look, for example, Al Gore's information highway.
Yeah.
It does with his father's focus on the interstate highway system. I mean, it's literally, this was the effort to build infrastructure. I mean, the information super high.
He picked it up at a state where, I mean, you had ARPANET, you had all of this stuff before Al Gore appeared on the scene. And he had a particular task, which was to get the NSF now out of NSF before the thing blew up in the congressional scandal. Because they'd allowed the contractors to violate their rules and move commercial traffic over the internet. I mean, and Al Gore was the guy who managed to get the bill which transferred a public asset into private hands quickly and effectively. I mean, but his wasn't the vision. His wasn't the vision which had created that ARPANET and all of the successors. So that,
No, but he did push this notion of infrastructure, the idea that it was, he wants, I mean, he really did make this analogy between road systems and the global information superhighway.
This was a marketing step rather than a conceptual step in what these people could build. They had a.
But it may have influenced PTAC in terms of their language and their talking. And so anyway, I just wonder if
the term infrastructure.
Correct. Yes. But anyway, I'm asking David.
Okay. Warming to Al Gore, yes.
But the question.
From Al Gore back to.
But no. But anyway, just to suggest, maybe not now, but I just wonder if because if you take it to the PTAC report, it's almost within the computer science, too much within the computer science community,
Sure.
and the larger political industrial policy in the U.S. actually had a potential influence in framing the PTAC report.
Sure, yeah.
So,
I would love to go in those directions eventually. Absolutely.
I'm reminded of the analogy.
Sorry.
Oh, sorry, I think it was here first.
I want to change the topic entirely, and if I'm out of court, please say so. But I need to declare an interest. I have had a long career in computing and partially in computer science, but it's not been in academia. And so all the while I've been involved in the whole question of the evolution of computer systems and what have you, and bouncing off academia. And every time I have get involved either in the fringes of these discussions, I eventually finish up being very frustrated, based on your idea of methodology, which is summed up for me by, there was an old thing, Tennyson wrote a poem about investigating a flower, and he's going on and on and on and on, and basically he's illustrating the old Zen thing, is once you've torn the flower apart, where's the smell? He's standing outside it and trying to dissect it and what have you, and trying to find out what makes it work. And it seems to me that the difficulty I have in communicating with everybody is I've spent my life in cyberspace facing up the problems of building cyberspace infrastructure, and and I've come to all sorts of conclusions which are similar to yours, but we can't communicate with each other.
God, we haven't even tried yet.
Well, what about the methodology question? I mean, was there a question specific?
Well, you talked in the preliminary notes on the website or what have you. You talked about designing information infrastructures. Now, my experience is you don't design information structures. Information is information and information. And what you actually do is find out what that information structure is, and then you relate to it. In the same way, when you talk about cyber infrastructure, you don't design cyber infrastructure. You are working in cyberspace. If we might have to have a debate about what I mean by that. You're working in cyberspace, and being on the inside, you actually begin to have an understanding, and it's almost a kind of emerging thing of what the infrastructure is, and then you need, whatever it is you're doing, to modify your methodology to suit the technology that is being provided to you. It's not a technology that you have built. It's
Can
not. Yes.
I try to help? Which is, what did the computer scientists within the projects that you've been looking at, how did they feel about your findings, and did they find some useful aspects of your research findings, and how does the communication go between the social science and computer scientists within your project?
Sure. I wonder if that does answer your question though. But let's go with it. This is a relatively new set of questions that I've begun addressing. A lot of the, like I said, a lot of the previous stuff was actually much more methodologically oriented than grounded theory. In other words, it was based in that GEON project very, very closely. And so I think on several occasions I was quite useful to them when I presented back to them. Let me give you. I can even give you an example. For example, when NSF did its site review, each out here project was reviewed on the 2.5 year mark, or officially on the 2.5-year mark. And when they did that, they asked me to present for them. And I was going to speak about the social communication and organizational issues, basically. What they wanted me to do is speak about the ways that within GEON, how is it going between the relationship between computer scientists and earth scientists, and also how is it going amongst those earth scientists? There's so many different disciplines, all the way from paleobotanists working on on a fossil and their data collection there, all the way to the geophysicists and their huge massive data sets and enormous experience working with these things. And so I would present on the ways that they've developed methods of communicating amongst themselves, methods of collaborating across those boundaries, and I can talk about some of those specifically, but I think they responded really well. And it's funny, if you look at the NSF report, there's a lot, the NSF evaluation, the thing that finally came out and they said about GEON, there's a lot of talk about cultural building. There's a lot of talk about community formation, and this is something that I think I can take at least some small part of the claim and say that I've introduced some of that thinking and language into GEON.
We have time for one more.
Thank you. My name's Paul Jackson. I'm here, I guess, as a member of the public, because although I used to be an academic, I work very much in local government nowadays as an IT advisor to mostly to local authorities. What I'm interested in is the ability to apply your ideas in that particular context.
Mm-hmm.
And I don't know how many of you know this, but there's a big, and we could call it an infrastructure project going on at the moment called Government Connect, which is a big IT project which exists to support English local authorities in basically joining up, sharing secure email, data sharing, just better secure messaging as part of that sort of joining up agenda. And I guess in one sense it's obviously an infrastructure issue, but I never quite thought about it as an infrastructure issue in the way which you've articulated it today. And I like the dimensions that you're setting out here, the shifting institutional terrains, because initially this was funded by government, and then the hope was to move towards a model where the local authorities themselves would buy into it. But lo and behold, in the sort of the second or third year, nobody was buying into it, so government had to step in again. So, things are really shifting. Technology is moving all the time. There are some authorities thinking, look, this is going to be old hat. There's going to be another way of doing it in a year or so time. And how you organise and sustain that, who actually owns it. I don't think people really know. We could have a change of government in 2 or 3 years, or we probably will within 7 or 8 years. What the hell is going to happen there? I think it's a really interesting multi-million-pound project to apply your ideas to. I don't know if
I'll take it.
Hanging around. It's
too late.
I don't know if you're hanging around in the UK for another few weeks or months, but it would be a really interesting thing to critique with the work that you've been doing.
I would love to have I have never had the chance to look. I'm Canadian, by the way. I'm not American, and so I consistently tie myself to these state-based projects, and I've never looked at an industry that foreign animal to me. But it would be very interesting to do so. Yeah.
This isn't an industry project.
It's not.
It's in the public sector. It's a difference between
That's why it's not working.
between local authority and and government.
Okay.
Central government.
Most local authority projects actually do work really well, better than central government ones, but this one is having difficulties, and I wouldn't like to be quoted on that, but it's not going as well as it could.
Just webcast.
I was watching my words very carefully.
That's right, okay.
But I think we could make quite a number of other comparisons with commercial infrastructures, with political infrastructures and so on. But I think one thing we've seen is that this generates quite a lot of discussion, and I'm sure David will be happy to take a few questions afterwards in an informal setting. And let's thank David again for a very...
Yeah.
very good.